Hello guys, today we are going to see how to create a list dynamically. Till now, whatever the codes we have written on list, say for example, we wanted a list of 5 numbers, so we wrote the instruction in this way, like we want to create the list and these are the content of the list. It is at the time of creation itself, in the source code itself, we hard coded the content of the list, right? So in this way, or suppose we want a list of names or strings, we wrote it like this: ABC and say PQR, and say one more, say 1 2 3. Okay, so this is a list of 5 numbers and this is a list of 3 strings. However, what we want in this program is that we want to create a list dynamically, in the sense that instead of like doing this hard coding, instead of specifying the content of the list in this way, in a hard coded way, what we want to do is we want to start in our program, we want to start with, say, a blank list, and then we want to ask the user, okay, now you tell me what are the content that you want to store in the list. So for example, we want to create a list of 5 numbers, okay, and we want the user actually to specify 5 different numbers, those we are going to store in a list. So this is what we're going to see in this video. Before actually writing the code, I want to tell you something more about this list. So till now, what I said you is that a list is it's a container that contains some subcontainers, right? Like, say, that contains some cells. Let's say for example, if it is a list of 5 numbers, then this is how the list is stored in the memory. Okay, that thing is right. But what you can think of this list, like how this list is different from a normal atomic container. Like, say for example, if you have written, say, n equal to 5, in that case also you know that a container will be created where this number 5 will be stored. But how this n is different from this a, other than, like, this obvious reason, like this a is a collection of some more independent or individual elements than this thing. There is one more significant difference between these a and n. So and it will help you actually going further in Python programming language. Okay, so I'll be telling you the story in a moment. So what happens is this a, instead of thinking this a as just a container, what you can think of this a as something, it's a as if it is a living object, or as if it is a living thing. Say for example, I just imagine this a as a tortoise, say. So it has a neck, and why I decided this creature, because I wanted this writing space to be as much as possible. I could have drawn a dog also, a cat also, but say z- and anyhow, this is an analogy that I'm going to tell you now. How different these now, assuming this a as just as a hotel that I gave you in my last video, most probably, like an analogy of a list with a hotel, and how it is different from an analogy of a list with a tortoise. Now, see, this tortoise is a living creature, right? So what does that mean is that you can think at least as not only a container. Obviously it's a container where you can store some data, not only a container, but also as if it's a living object, as if it is a living thing. How a living thing is different from a non-living thing, that you can actually communicate with that living object in that sense. That is what you can ask the tortoise to do something. Say for example, what you can ask this tortoise to do, say for example, you can do like, okay, you create a new cell, create a new cell. And so immediately what this tortoise will do is, it inside these whatever the cells it is maintaining, it will create a new cell inside these in its list actually, or in its collection of cells. So I guess people understood the point here. So what is the point is that you can pass a message, or you can instruct this living thing, living object, to do something. So what you can do is one instruction, such instruction could be like create a new cell. So create a new cell. As soon as this tortoise receives a command or an instruction, what it will do is it will create a new cell inside its collection of cells. Or what you can do is you can ask the tortoise to say, for example, remove the last cell, remove the last cell. Okay. Or you can say like create a cell at say for example second index. Okay, that is not only like when you say create a new cell, always it will assume that you are asking the tortoise to create the cell at the end of its collection. Or when you are asking it, or explicitly you can mention like where exactly you want to create the cell. Say for example you want to create the cell in the second index, so it means it will create the cell here, as the second index of that is at the second index. It will make some more space and it will create a new cell there. So these are the instructions that you can actually give to a tortoise, or like that is the analogous term. So you can give to a list. Okay. Now see here, things should be clear. Okay, if it is not, then you pause and you just think for a moment. Now see, one more thing I want to tell you here, that whenever you are writing a program, it is not like, say now say for example you are an animal lover. So you are an animal lover, and what you do is you love this tortoise very much, and not only one tortoise you want multiple tortoise. Okay, so what you do is you have multiple tortoise like that. You have one, and you have two, and you have, say this one is your three, the third tortoise you have. Okay. Now as soon as you have multiple tortoise, then what you would like to do is you would like to give them some name. Say for example this is tortoise one. Say you can call it by any name. Say you're calling it by the name, say A, by the name B, and by the name C. So whenever you want to give an instruction to any one of these tortoise, then you explicitly you have to mention that thing, right? Say for example you want this, see all these tortoises, they respond to the same three messages. Say for example same three instructions you can give to these tortoises. Like say you want like this tortoise also maintains some internal cells, this also maintains some internal cells, and this tortoise also maintains some internal cell. But what you can do is you can give instruction to these tortoises independently. That is, if you want to give that is, if you want this tortoise to ask like, okay, you create a new cell at the end, how you're going to tell it? You're going to tell it programmatically. If you want to do that, you can do something like this. That is, the name of the tortoise you have to write. Say the name of the tortoise is A, so this is the tortoise to which you are actually going to pass the command. Okay, and then you have to write there a dot operator. So a dot, okay, it means that the computer will understand, okay, it is you are actually trying to pass a message, or you are actually trying to give a command to an object whose name is your A. So that object is a general term. Specifically here in this example, in this analogy, that object represents a tortoise, say. Okay, so a dot, and you are calling it, say you want to perform an operation. See, for all these, this is the general description of the operations that you can perform on a, or that this is the general description of the instruction that you can pass to a tortoise. However, this they have in programming world, all these operations have some specific like name. Say for example, to do that thing here, you'll be calling a function called append. Okay, this is your instruction. To remove, the instruction is pop. If you consider that a tortoise is actually a list, and or it is create a cell at a second index, or at a specific index, that instruction will be insert. Okay, I'll be showing you with a concrete example. Just now we are in the middle of a uh, you know of a discussion actually. So anyhow, a dot append, that is, what does this mean is that you as a programmer want to pass a command to this tortoise. Okay, a dot append, and what that command is, you are passing this command, like you are issuing this command like append. As soon as this tortoise receives this command append, it knows what exactly it has to do. It knows that internally it has to create another cell at the end of the list it is maintaining, and there you want at the same time to store something. So that something, say x, you have to specify. Okay, it means what, whenever you are giving an instruction, like giving this append command to any specific tortoise, this is how you have to do that thing. That is, the first thing is, any specific tortoise means to which tortoise you want to pass the instruction. Say for example, you want to give now the tortoise C an instruction, okay, and then you have to write what operation you want to, you want that particular tortoise C to carry out, or to perform. And say for example, that operation is your pop. And then you have to, like, if that operation needs some input, you have to specify. If it doesn't need any input, then you just do not have to give any input. Okay, so for example, append, whenever you ask the tortoise to append, it means obviously the question is that what you want the tortoise to append at the end of its existing list. But whenever you are asking, like say pop means, say, remove the last cell. So it means here you do not need to specify anything. I know this is like, all the information is there in this instruction, c dot pop. It means you are asking tortoise C that you remove the last element present there in the list. Okay, now these tortoise, whatever I said, these tortoise, no, these tortoise thing, you now replace that tortoise word by, and by this more technical term which is called as your object. And usually you will see in Python writing syntax in this way, like you write the name of an object, say object name, it could be anything, okay, the name of an object. When you see some concrete example, it will make more sense. But anyhow, the syntax, let me tell you, the object, and then you have to make use of this dot operator, and then you have to write here, usually you write here a name of a function. It's a function name, okay. And then within this parenthesis, you have to, if the function needs any input, then you have to give, you have to specify those inputs here inside this parenthesis. This is the general syntax of executing a function on a given object. And what I said is, these lists are like, actually they are not they are not simply a collection of some individual cells. They are actually objects. A list is, you know an object. Actually, whenever you are creating a list, basically you are actually creating an object of type list. Now you see, let's see some more example, like see some concrete example, and then things will make more sense to you. Okay, let's start with a blank list, because we want to create the list. Our goal is still, we have to create the list. No, we have to create the list dynamically. That is, we are not supposed to hard code the content of the list. So what we'll do is we'll start with a blank list, and then what we want is, like, okay, when I create a blank list, like when I write something like a equal to blank, you can think as if I'm creating a tortoise who initially or who internally maintains a blank list. The name of this tortoise is A, actually. Okay, and internally right now it doesn't have any cells. I mean, it doesn't have any number at all. No data it is maintaining. Okay, that's a blank list. You can assume, or you can think, or you can imagine it in that way. After that, what we want is, we want to append some content at the end of the list. Say we want to execute operation on that particular list. Now to that tortoise we want to give some instructions. So for example, a dot append, and then I pass here a number. So what am I doing here is that I'm asking the tortoise A to append the number 12 at the end of its list. Since we started with this blank list, so as soon as the tortoise receive, or as soon as the computer executes this line, append, as if I'm sending a message to tortoise A to append the number 12 at its no, at the end of its list that it is maintaining. Now see, this tortoise will receive this command append 12, and it will see that it's right now it has nothing in its list. So what it will do is it will simply create a new cell in its list, and it will have the index 0, and that's all. And you just have another tortoise will attend this 12 append this 12 as its only content of the list. And then let's say see what is the content of the list. So print A. So if I execute, you'll see that only one thing is there in the list, that is your 12. And see, after that, suppose we again want to add one more number at the end of the list. So again, to the same tortoise, I'll be asking, like, again you do the same thing. A dot append, now say 23. And you see right now suppose we want to see what is the content of A. After executing this a.append 23, we'll see that in the list we have now two numbers, 12 and 23, where 23, that new number, was inserted at the end of the list. So this is what this append function is doing actually. And also you should realize that, see, you might have two tortoise, right? So say for example, you have another tortoise and list. I'm using now interchangeably. Tortoise is the analogy world, and this list is the, the term that I'm using when I'm talking about the programming world. Okay, so b is equal to, say, this is your another tortoise, and which is also blank initially. Now see, if you pass this command, if you are, if you are like giving instruction to this tortoise A, it is not, this tortoise B is not going to respond. Okay, what I mean is, see, both these two instructions you send to A, like you asked this tortoise A to append 12 at the end of its list, and then again you asked the same tortoise A to add 23, or to append 23 at the end of its list. And at the end, if you see, you have, like, the content of that tortoise, like if you ask the tortoise now to show its content, then it will show you 12 and 23. However, at this point, if you see the content of the tortoise B, you will see that the content of the tortoise B is empty. Right here, B is empty because you didn't say anything, you didn't ask tortoise B to do anything. uh, Here in this image, if you want to see, then if you have another tortoise, say B is equal to a blank list. So list I am representing with the help of a tortoise, and say this, both of these A and B started with a blank. However, since you gave this instruction to tortoise A will create a new node, and I will create a new cell, and it will consider, okay, that is the content of the list now. Then again, suppose if you pass another instruction to tortoise A, say for example, again you are asking tortoise A to append, say, 23 at the end of the list. So what it will do is, this tortoise A will respond. However, tortoise B is still sleeping, it will not respond to your call. So tortoise A, what it will do is, it will append 23 at the end of its existing list. So existing list means that moment when the when the tortoise received that command, that moment it internally, its list had one element, that was 12, which you inserted previously in the previous command. So these command a.append 23 will, it will make this tortoise to create another node or another cell at the end of the existing list, and in that cell you are asking to store 23. So that way it will become the second cell, that is the cell at index number 1 for this tortoise. Okay, so that way you see here, now this is the name of the object on which you want to perform these operation. Okay, this is the name of the object, and this is the name of the operation that you want to perform, and this is the input if that operation needs any input. So here you see, this is object name, and this is name of the function. So this is technically function name, and this is the input to the function. Okay, that is your, you can say function input, if any. Okay, all the function might not need any, some of the functions might not need any input. We'll see some more examples. So here, when I say all the function doesn't need, all the functions might not need any input. Say, let's say another function or another operation that you can, or another instruction that you can give to a tortoise. Say, you are again asking the same tortoise A, and you are asking it to, say, no, remove the last element which is there in its list. So, and if you execute, you will see 23 is coming. This number 23 is being displayed on the screen, and this 23 is actually this 23. Okay, let me make the things more clear. Say I remove this tortoise B now from the picture. Initially I had only this blank list, so just to make sure that the list is blank, let me show you the content of the list. It's blank, right? And after that I that we give as a programmer, we give instruction to tortoise or list A. So I want to issue a command, or I want to give an instruction to list A. So that's why I'm writing here the name of the object here is your A, and dot, that dot operator specifies. See here, as soon as I write a dot, you see that all these different these tortoise, this list is responsive to all these different functions actually. That is, on this list you can actually perform all these different operations. So remove, reverse, sort, pop, insert, index, extend, count, copy, clear, and append. We'll see some of them in this program or in this video. However, it should make sense now. See, this A is the list on which you can perform this set of operations. So the operations, the operation that right now I'm talking about is this append operation. What does it do? It creates a new cell at the end of the existing list, and it stores the value that you specify as an input to the function. So for example, 34. So this will append 34 at the end of the list. Now, again, if you perform the same operation, a dot append, say 98, and then again you perform the same operation. That is, you issue the same instruction to the list A, and you ask the list to append say 32 again at the end of its list. Now see, first time when you say add 34 at the end of the list, it will create that, mentally you should visualize the thing as if like you're creating this 34 first node, 98 second node, and 32 is the third node. Okay, so if you want to see now the content of the list, what you can do is you can use this print function, print, and you pass this the name of the list that you want to see. So as a result, you will see that, okay, see, 34 is the first number because that was the first number that you appended for the first time. Then 98 is the second number, 32 is the third number. Done. Now let's see like some other operations or other instructions that that you can pass to a list. So for example, a dot. Another one is your pop. What does this pop function do? If this pop function actually, it removes the way this, it does the reverse thing that this append function do actually. Say this append function appends, or it creates a new node at the end of the list, and this pop function actually, if you do not specify any input here to this pop function, what it will do is by default it will remove the last element from the list, and it will return that element, or it will return that number, or the content of the last cell to the program. If you want, you can store it in some temporary variable, and then later on you can display it on the screen. The print now X. And also I want to show you the content of the list A after popping out the last element. Okay, let's see. Print A, initially you are seeing this blank, and then A dot append 34, 98, and 32. So, and after that you are displaying the content of the list A, which is 34, 98, and 32. And after that, print A again. So this is the, like, this print A is printing this 34, 98, and 32, and then you're writing X is equal to A dot pop. What it will do is it will remove the last element of the list, and it will return it to the program. So in the program, you're storing the result in the variable X, and then you are displaying the value of the variable X. So as a result, you can see that this 34 is coming on the screen. And since these pop removed this last element from the list, so after executing this pop, if you see the content of the list, you will see that the list contains only two elements at this point. So at this point, this A contains only two elements, 34 and 98. Now let's move to the main goal of our program. So we started like we wanted the user to specify the content of the list, and we wanted to create the list dynamically based on the content of the user. Okay. So to do that, what we want is, okay, let me create another code cell, and there we'll be doing it again from the beginning. What we want is, we want these blank list. We want to start with a blank list. Okay, done. And then we want to create a list of say 5 elements. So that's why I stored this number n equal to 5. So that, why? Because see, we want to ask the user repeatedly to enter 5 numbers. Say for example, enter first number, enter second number, enter third number, enter fourth number, enter fifth number. Since you want to do the same thing again and again repeatedly, so what you'll be doing is you'll be using a loop. So again, since you want to use a loop, you need a loop variable. So I'm using say I, while I is less than n, that is as long as the value of I is less than 5, you want to ask the user to enter something from the keyboard. And what is the instruction for that? So that is your input, and then you can write here a string. That string will be displayed to the user as a message. So say for example, enter a number. Okay, and then this colon. Now see, this colon is, side note, this colon is not a part of the syntax. It's just like it, since I have written this colon within this double quotation, it will not be treated as a special symbol. It will be treated as equally as this R or this E or this B is treated as. Now, this colon is completely different from this colon. This colon is part of the syntax. It always comes with this while loop. However, this colon, I just wrote it there. Like I wanted this colon to display as it is on the screen. Okay. So that, and then what we want is whatever the user enters, that thing we want to append at the end of the list. So what we can do is we can ask this list A now. Okay, that is you can give instruction to list A append, 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 and then within bracket. See here, these thing, this is the instruction that you are passing, or this is the instruction that you are giving to list A, and what input you are giving along with this function. What is the input to this append function? That is what you want the list to append at the end of its list. Whatever the user enters from the keyboard, this input, whatever, you know that this particular instruction, when it is executed, it will return the program whatever the user types from the keyboard, and press the enter key. You will see it in when we execute the program, things will make more sense to you. So anyhow, that way, whatever the user enters, it will go directly at the end of the list A. And after that, since we want to also keep track of like how many numbers we already asked the user to enter, so for that reason, as part of our logic, what we'll do is we'll write I equals I plus 1. That is, every time we accept a number from the user, we'll increase the value of I. And as soon as we like finish accepting 5 numbers, we want to terminate our loop, and that will be done using this condition. So as soon as the value of I becomes equal to n, we want our loop to terminate. That is, we want our control to reach this point. So here, if you print the content of the list A, then you will see that it will display you whatever the numbers that you entered when like when the program asked you to enter those numbers. Let's see it in execution. If I click here and execute, you'll see, okay, see here, see as soon as I click on this button, play button, when I execute the program, what it is doing is it is displaying me the message, enter a number along with this colon. So it is exactly the same thing that I wrote it within this double quotation. This is the string which is being displayed here. And then due to these input statements, since see here, you should realize that right now this input statement is getting executed. So as a result, it displayed you this message on the screen, and it is now waiting for the user to enter something from the keyboard. So as long as I do not type anything, and as long as I do not press my enter key, the control will always remain here. That is, it will not proceed. See this arrow mark here? It shows like this is the current instruction which is being executed by the computer. And if I do not do anything here, the control will still remain there, like till I press my enter key. Okay, so I write the number, and then I press 67 and I press enter. As soon as I press enter, immediately it will do it will go to the next instruction, and again it will go back to this condition, and it will check the condition, and it will, if the since the condition is still true, because see, after the first iteration the value of I will become 1 less than 5 true, so again it will come inside the loop, and then again it will execute this instruction. So as a result, again you will see the same message on the screen, and it is still waiting for me to enter some more numbers from the keyboard. So suppose I write 32 and I press enter, then it will again ask me the third number 21, enter, fourth number 45, enter, and the fifth number 90, enter. As soon as I enter this number 90 and I press enter, what will happen is this value of I will become 5, and when the control reaches back here and checks this condition one more time, it will find that this condition is no longer true, and as a result the control will go out of the while loop, and as a result this print A will be executed, and as a result you will be able to see whatever it is the content of the list A. which is 67, 32, 21, 45, and 90. See, 67 is the first number that you entered, 32 is the second number that I entered, 21, and 45, and then 90. One side note you should realize here, that although I entered some numbers, you should see that when the content of the list is being displayed on the screen, those numbers are actually treated as strings. So you should know that fact. Actually, these input statement returns whatever the user types from the keyboard. It assumes everything as a string, and so as a result, these list is actually it is considered as a list of strings, not as a list of numbers. However, that is just a side note. You can always convert a string to a number. That's not a big deal. So, and that is not the main concern of this video. The point here is that you should know, like, how. The point here is that my main point here is these dot operator and these functions and these object. Here we just learned that on an object we can pass some instructions, some predefined instructions, certainly, and those instructions can be carried out. So see, whenever you are seeing some instruction or seeing some Python code that looks something like this, you just interpret that thing as if on the left hand side of this dot operator there is a tortoise who is waiting for your command, and that command that you give to that tortoise is this command, this name of the function, and whatever you write inside this name of the function within these two parentheses, that is actually is input to that function. Okay, that is, you now here again one more time, last time, you are giving this tortoise a the command to append whatever the user types from the keyboard and presses enter, that thing you want this tortoise to append in its list. That much only for today. I hope if people enjoyed and learned something from this video, and let's see you in the next video.